Okay, now I'm going to talk about the rational zero theorem. It's a way to list out possible candidate zeros that you can use to find the zeros of a function, of a polynomial function. So here's what the rational zero theorem says. Basically, it says let the constant term be equal to p, and let the leading coefficient, which is an implied 1, let that be q. All the possible rational zeros there could be is the set that is plus or minus p over q. And it's that simple. So here in this case, p is 6 and q is 1. So the possible zeros are the factors of p, the factors of q, and the factors of p over q. That's a way to find out which zeros to use. So the factors of 6 are going to be 1, 2, 3, and 6. And of course, those aren't the only ones. Those aren't the only zeros we're going to test. We're going to test a -1, -2, -3, and -6. Those are the zeros we're going to test. And we test those by putting it in the into synthetic division, dividing each of these synthetically into the function. So I like the look of 2. Let's start with 2. So 2, that's going to be 1, -2, 4, and -6. So we divide synthetically. That's going to be 1 after we drop down. 2 times 1 is 2. -2 plus 2 is 0. This becomes a 0. That's a 4. 2 times 4 is 8. And we have -6 plus 8 is 2. So we have a remainder of 2 here. So it's kind of close, but it's not a 0. Now basically just go through this list and see which ones are zeros and which ones aren't. Remember, you can use the boundedness theorem to find out where these zeros are and if you're too high or too low on your tests. Now, let's do another one of finding possible candidate zeros. And it's a tricky one because when A is not 1, it gets really hard. So, I'm sorry. Actually, I'm sorry, I read the definition that only p and p over q are candidate zeros. So let's try 3x to the 4th minus 2x cubed plus 5x minus 3. Actually, to make this fun, let's make it 32. Alright, so we list candidate zeros. 32 is our p, and 3 is our q. So for 32, we have 1, 2, 3, 4. It's not divisible by 6. So it's 8. 32 divided by 3 is going to be... I'm sorry, it's not even divisible by 3. It's summer. This is why if you use it, you don't use it, you lose it. And this is where bad math comes in. So, 1, 2, 4. It's not divisible by 6. 8, 16, and 32. It's just powers of 2. And then our q is 3. And so we just put 3 over all of these. It's going to be 1/3, 2/3, 4/3, 8/3, 16/3, and 32/3. And of course you tack on minus signs to all of them in here. So those are candidate zeros, and you just have to put those into synthetic division and see which ones work.